encoder part, so these two sublayers, the self-attention mechanisms, feed forward neural networks. So if you want to implement this using Python, then you can use very easily these self-attention mechanism by using the dependencies and by using the ReLU activation function. Next, at the side of the output is decoder. So decoder in transformer also consists the multiple identical layers. So it consists the multiple identical layers. Its primary function is to generate the output sequence based on the representations provided by the encoder and the previously generated tokens of the output. When you implement this tokenization, then you can easily understand the previously generated tokens of the output. So each decoder layer consists of three main sublayers. In the last, encoder based on the two sublayers and decoder consists three main sublayers. Masked self-attention mechanism, encoder-decoder attention mechanism, and feed-forward neural networks. In the first of sublayer of the decoder, the masked self-attention mechanism, its main purpose is to prevent attending to future tokens to maintain the auto-regressive property. Because the name here is masked. So prevention of the attending to future tokens to maintain the auto-regressive property. Encoder-decoder attention mechanism. This sublayer of the decoder allow to focus on the relevant portion of the encoder output. And this allow also the decoder to focus on the relevant parts of the input, and that is essential for tasks like translation, because in attention mechanism we always focus on the input parts which are very relevant for all of us. Feed forward neural networks. This sublayer processes the combined output of the masked self-attention and encoder-decoder attention mechanisms. So in decoder, three main sublayers are available. The masked self-attention mechanism, encoder-decoder attention mechanism, and feed-forward neural networks. So if you want to do research in this domain, so you have to be very sure about the input representation, right? So input representation includes the tokenization, embedding, positional encodings. So what is the tokenization? What is embedding? What is encoding? You must be very clear about these. Tokenization is the first step because it is the processing of the input data, involves converting the raw text into formats that transformer model can understand. Specifically tokenization, the input text is split into smaller units, and these units called as tokens, which can be a word, which can be a subword, which can be a character, because these are the subunits. And subunits, smaller units, and these are called as tokens. Tokenization ensures the text is broken down into manageable pieces. We cannot break the word or character in such form that is not manageable. So be ensure that about the text is broken in such a manner that the piece is manageable. Piece is manageable. So next is the embedding, right? So embedding means each token is then converted into fixed size vector. And here vector, fixed size vector specifically. We have dynamic size of vectors as well. So in embedding, by using embedding layer, token is converted into the fixed size vector. And this layer maps each token to a dense vector representation that capture its semantic meaning. So positional encoding are added to these embeddings to provide information about the token positions within the sequence. In the second, first you identify the tokens, you identify the embeddings, you identify your input representation, then you go for the encoder processes. So input embedding, self-attention mechanism, feed forward network, layer normalization, residual connections. So this is one of the use case. Here, encoder processes in transformer, it means the input sequence is tokenized and converted into embeddings with positional encoding added. Self-attention mechanisms, feed forward network, layer normalization, all you can see here. Decoder processes, input embedding and positional encoding, masked self-attention mechanism, encoder-decoder attention mechanism, feed forward network, layer normalization, residual connections. All these parameters of the decoder processes are. Here, important term is training and inference. So, as a researcher point of view, so transformer are trained with the teacher forcing, where the correct previous provided during the